Okay, everyone. It is Tuesday. Yesterday after the spring break. If you weren't with us yesterday or didn't watch the blog, we started the intro to graphing and linear functions. So this is the unit that we're going to start to use the graphing calculator. Again, we'll have to cross that bridge when we come to it. We won't be using the graphing calculator today, but if you did download that stick, I suggest you start to get used to playing around with the simulator, the graphing calculator on the computer, the virtual calculator. I know some of you downloaded the app on your stick and use on your Android phone. The other application that we'll have to use, since many of you didn't make it in for that last week of school, we'll have to use perhaps the Desmos app on a computer, just like on a laptop. And again, it's an app that it's a website you can visit. You don't even have to download anything. You can just visit the website and to do everything that we do in class with the graphing calculator on Desmos. I'm just trying to figure out how I am going to expose and teach a class using the calculator and Desmos at the same time. So that's something I'm going to have to probably start doing tomorrow. So I might actually do a different live stream, might look a little different. I might be live streaming just with a computer screen and not with my notes, but we'll have to see how it goes. I wouldn't mind some feedback from everyone if anyone's watching. So yesterday what we learned what the Cartesian coordinate system is. It's the XY axis that I'm sure you've seen in other math classes and also in science classes, right? That's how we graph our data. We collect raw data and we graph it. Just graphing a point, we know that a coordinate point, if I plot a point on a grid that looks like this, I have two axes, an x-axis and a y-axis, the horizontal, the vertical. So therefore I need two identification numbers, right? I need an identifier for the x-axis and an identifier for the y-axis. So the first number, the information is given to you in a coordinate point. The first number references where on the x-axis that I look for the value. So if they gave me a 6,3, I look where 6 is located on the horizontal axis, and then where 3 is located on the vertical axis, 1, 2, 3, and that's where the point 6,3 is. So we learned about coordinate points. Then once we plot when we're given raw data or we collect raw data, perhaps in a science experiment or something like that, sometimes our data can be displayed in different looking patterns, right? Sometimes we get a pattern like this where all the dots seem to travel sort of upward in an upward movement, and we call that a positive correlation. Sometimes the data looks like it's kind of falling, moving downwards, and I'm reading left to right across the page, and we call that a negative correlation. Sometimes there is no change at all, right? The dots just march along the page and don't change at all. Their vertical distance from the ground doesn't change, so it's a constant. And then sometimes there's no pattern at all, and we just call that no correlation. It's just like a scatter, just someone took paint and flicked it against a wall. Okay, so the other thing you're going to have to be doing, even though we'll be using technology to graph our graphs, something that you'll also have to do is a pen and paper graph, right? So Applied blends both the technology, so graphing using a graphing program or a graphing calculator, but it also tests your skill in a pen and paper. So we did one graph yesterday with pen and paper, and we kind of learned how to set the graph up, how to create a scale, like pick the numbers that go on the scale, and that's kind of arbitrary. You can choose different scales. I chose a scale of going up by tens and then going up by ones on my x-axis. But there are you can use different scales. You're only constrained by how much space you have, right? What the numbers are that you have to work with, how much space you have. There's one rule that whatever you choose as your scale, if I make this first tick equal to 1 unit, then all the ticks after that have to be ones as well. Going vertically, I made the first tick 10. had a value of 10. So every subsequent tick had to have a value of 10. That's the only rule, right? I'm going to continue on with that today. I'm going to do the rest of the examples. It's very important that you get used to some graphing skills, like we said. So I'm going to work through examples 2 and 3 and 4 on the opposite pages. Then I'm going to assign some work for you to do for homework. And then tomorrow we'll regroup and we will be talking. We will actually introduce some technology. So tomorrow is a very big day. And again, you'll have to either have some way to use your graphing calculator on your computer while I'm talking, or if you don't have your graphing calculator, you'll have to have Desmos open, one or the other. Okay, plot the graph of the data provided in the table. The table provides data about the speed of a vehicle and its stopping distance. So this is how fast the vehicle is going. This is the stopping distance. To me, it would make sense. I would just think just logically that the faster I'm going, the longer it takes me to stop, right? But we'll see what that happens when we actually graph this. So in order to graph, remember, these are all the important info that you should be thinking about. I'm just going to raise this a little bit. I need lots here. Okay. So in order to pick a proper scale, on my vertical and horizontal, these are the questions that I have to answer, the same as we did yesterday. What's the minimum X value? So remember the first column, if you're given the data in a chart, like this is a coordinate point, right? 50, 14. So the first column is always your X info. The second column is always your Y. It follows the order of the alphabet. So let's see. And quite often your data is not given to you in order, right? Your numbers don't necessarily go from small to large. On the X column, it just depends on how you collected your data. So you have to be very careful about this. What's the largest, or sorry, the minimum X value? What's the smallest X value? I guess it's 30. What's the largest X value? It is 150. Okay. What's the distance before stopping? The smallest distance before stopping is 5. And the longest distance before stopping is 126. Okay. So I have to, so on my X value, and I could label this as, right, my horizontal axis is the X axis. So this has to be labeled in speed, kilometers per hour. And my vertical axis is my Y. I'm just going to flip this for a sec. Distance before stopping. And this is measured, in meters. So you have to have your title and your units. Okay, now remember yesterday I kind of ran out of room here and I started at 0 and I had to go to 100 and I had, a lot of numbers to explore here. Well, I have the same thing happening here too, right? So let's see what happens. I've got speed from 30 to 150. So I have and I've got a couple of ways you could do it, right? I've got, let's see, if I have to go to 150, it's nice to start at 0 if you can. If you can't, sometimes we have to, we can make adjustments there. But if I start at 3150, I have to go a space of 120. So let's see, how many spaces do I have moving across? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, about 15. I think if I went up by tens, I think I could get to 150, right? Because I have 15 spaces. I have to go as high as 150. Let's just try. I'm just kind of playing around here. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 120, 130, 140, 150. So that works out pretty perfectly, right? So I'm going to start at 0 and I'm going to go up by tens, right? 10, 20, 20, 30, 40, 50. Okay, so I'm not putting all my numbers just because I would find it too messy. So I'm only going to put every 50, 60, 70, 80, 90, 100. 110, 120, 130, 140, 150. Now, if you want to record like the 20, 30, 40, by all means, you need at least, I'm going to say at least one number to show the scale, but I like doing a few numbers just to keep myself on track. So when I actually point my plots. So see what I did there? I just counted how many spaces I had, how many numbers I had to go up to, and I just chose my scale that way. You could certainly have chosen something else, but just remember, I couldn't choose 2, for example, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, because I wouldn't have enough space for all my numbers, right? I would get to only like 30 here. I need to go to 150, so I had to pick a fairly large scale. So scale from my x-axis is 10, okay? Meaning I by tens. Let's see how many spaces I have vertically. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16 spaces and I have to go to 120. So if I have 16 spaces, if I went up by 10, 160, that would be enough. I mean, maybe I'll go up by tens again. That doesn't always happen, but if I went up by tens, right, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 12, 10, 20, 30, 40, 50, 150. Okay? So it's just a coincidence. It's how the data fell that I'm using tens for both scales. That didn't happen yesterday. If you remember yesterday, we used a scale of 1 for X and 10 for Y. So that doesn't always happen, but it just kind of fits the data this year applied math, especially in the grade 12 course, for sure. You have lots of graphs you have to create from data. I just see a message that I saw a message that my connection was unstable. So a good graph needs a label on each axis. So a descriptive label and then the units. And then you need to indicate what your scales are, okay? So let's see, now we're gonna just plot these points as best as we can, right? It's quite difficult to plot some points with raw data on a graph because we're limited by what our grids represent. And sometimes that's not always easy. So my first data point, 50, 14. So X is 50. Remember this, each tick on my y-axis is equal to 10, right? So if I just want to get this started, 10, 20, 30, 40, 50. So 50 comma 50, 14, sorry, would be about here, right? Now notice I'm kind of guesstimating, but I'm making a good guess. 14 is between 10 and 20, and it's closer to 10, so I went a little under my half, okay? 80 comma 36, so let's see, 50, 60, 70, 80, 10, 20, 30, 36 would be about right here, I think. Okay, so I've done these two. 60 comma 20, so 60 comma 20, that's an easy one to graph. Okay, done that one. 110 comma 68, so 110, 10, 20, 30, 40, 50, 68. Okay. 40 comma 9. 40 comma 99 is just under that 10. Right? 30 comma 5. 10, 20, 30. And 5 is right in the middle here, right between 0 and 10. And then 150 comma 126. So 150 comma 126. Okay, I'm going to travel all the way up to 100, 110, 120, 126. Okay, so this is what's called a scatter plot because I'm just plotting the points. I'm plotting my raw data, and I can see that it definitely displays a positive correlation, right? My data points appear to be moving upwards when I read my graph from left to right. So here it says, for part B, examine the graph of the data you plotted, explain what the data is telling us, specifically about the correlation between the speed of a vehicle and its stopping distance. Well, I see, oops, there is a positive correlation. Okay, we learned those words yesterday. And that means if it's a positive correlation, as the speed increases, the distance from before stopping increases. So we say that as the speed increases, the distance before stopping also increases. Right? Which is why they say speed kills, right? Because the faster you're going, the longer it's going to take you to stop. So in the event that you have to stop quickly, it's very, very difficult to stop, and you may end up hitting something or someone. So that's how we create this graph. So I don't know if there are any questions. I know a couple of you are watching. So again, we're just doing pen and paper today. Tomorrow we're going to start technology, but that still doesn't mean you will never do a pen and paper graph. Quite a bit of the grade 12 course also involves transferring the graphs that you see on your technology onto a piece of paper, right? So you knowing how to graph is very important, which is why I'm spending some time on it. Now let's take a look at example 3. So example 3, I don't know if this is going to work. You can see they don't give us a grid. They just give us an X, Y. Now remember, this is actually part of the coordinate system. Again, I mentioned this yesterday, that quite often, this is just part of the Cartesian coordinate system. And remember, the Cartesian coordinate system is where you have an X and a Y axis. So for example, this is our Cartesian coordinate system, right? This is my X-axis, this is my Y, and I know they're just two number lines put together. And here's my X and Y axis, but it looks like there's a big chunk missing. That's because we're only worried about quadrant 1, right? Quite often, in applied math especially, we don't need the extra 3 quadrants, so we only use quadrant 1. And that's because in applied math, lots of the application questions just involve positive numbers. And remember, in quadrant 1, everything's positive. So if we don't need the full coordinate system, we don't draw it. We just want to show the positive and negative sides of Y. So that's why this is 0, right? Okay. This is the origin, right? The point 0, 0. This example 3 talks about the number of kilometers per hour over the speed limit and the amount of the fine. Okay, so if you're going really fast and you're traveling too far over the speed limit, you're going to have to pay money, and the amount of money you pay depends on how much over you are going. So let's see what happens here. First thing I'm going to do is, so we want to plot this data. So this is my label. So this is the number of kilometers over the speed limit. And I guess the units would be in kilometers per hour, right? And then this label is the fine. And the unit for fine is, of course, dollars. Okay, we have to pay our fine in dollars. Now let's see, it's not guiding us, but remember what we did yesterday? We found our minimum X value. So this is the minimum. And the maximum is this one. Okay, so I have to go from basically, I guess, from 0 to 50. Okay, now it's not giving us guidelines. Some students like this better because we're not constrained to those little grids. And some students find this a little, maybe a little anxiety inducing because you have to pick your own scale. But this is quite nice to do. And also this is what comes to you on the grade 12 provincial exam, which I'm sure you'll be writing next year. if you continue on with your applied. They just give you blank spaces like this, and you have to pick your own scale and your own ticking system. So if I think about it, if I kind of stick to my 10, 20, 30 thing again, let's see, I have all this space on my graph. Let's see, or maybe I'll flip around to inches. I have a little, I strongly suggest you guys getting rulers. So if I use half inches, 10, 20, 30, 40, 50, I think that's what I'll do. I'm going to use half inches. And you have to, for the last two graphs, the grid was given to us, so we knew that that was perfectly portioned off. If you have a blank grid like this, you have to use a ruler and make sure 50. Okay? Hopefully that makes sense to you. Now let's take a look at the Y data. My lowest, my minimum is 85. My maximum is 190. Okay, so let's see what happens here. Now, because my data is, I'm going to show you something else you can do. For the Y-axis, quite often your numbers get very large. And I can see I don't even start counting till 85, right? So I'm going to show you something. Sometimes this can help you a little bit on your Y-axis. So what you can do is you can do if you do a lightning bolt, okay? So kind of do something like that, or you can use a double hashtag. That means I can start after 0. My first tick can represent anything. Like I can just put a tick here. For example, by tens again. Let's see what will happen here. I'm going to use centimeters this time. 80, 90, 100, 10, 20, 30, 40, 50, 60, 70. No, it's still not going to be enough. If I do 80 and I go up by 20s, 80, 100, 120, 140, 160. Or let's see, if I go up by 15s maybe, 85, 95, 100, 105, 110, 120, 130, 140, 150. Nope. Okay, let's go 85. 100, 115, 130, 45, 60, 75. I think I'm going to go up by 15s. Okay. So now what I'm trying to say to you is if I put a little hashtag or a double hash mark or lightning bolt, I can start with any number I want. But after that, I have to continue on going with I have to pick a scale and I have to be consistent with that scale. So I'm using these little notches, these little 5 centimeter marks on my grid. So see how I used the marks on my, and I marked every consistent tick with the same amount. So if this is 85 and I'm going to go up by 15s, I think I decided. So 85 plus 15 will be 100. Okay. Then my next hashtag will be 115 if I just keep adding 15s. Remember, this will get a little easier when we start using a graphing calculator, right? This is a little difficult, especially if you've never, and I've got 190, and that's as far as I need to go, to be honest, but I could add one more if I wanted to. My next one will be 205, okay? Now I have to graph these coordinate points again. Okay, 50 and 190. Now this is a little hard, right? So maybe you want to use your ruler again just to kind of stay in line here. So my 50 would be about here, right? And my 190s, but here's, this is where my dot would go. If you have graph paper at home, you could definitely use graph paper. You don't have to use the blank space, but just remember, next year in provincial exams, they give you blank space. You do have to, at some point, kind of get used to graphing with blank space too. Okay, so I did that one, 10 and 90. That's going to be a little easier, right? Okay, 90 will be kind of in between here somewhere. So just do the best you can. 25 and 105. Okay, 25 is easy. And 105 would just be a little past the 100, right? So maybe about right here. 5 and 85. So 5 is here and 85 is here. So here we go. Okay. So that was a little more difficult to graph because of the blank space and no grid provided. However, I still say that there's a positive relationship, which probably you knew before we even graphed, right? This is quite something, involves common sense. Obviously, the more you're going over the speed limit, the higher your fine. So explain what the data is telling us. So it is a positive correlation again. It is a faster you are going. Okay, so the higher number of kilometers, right? The more you pay. In fines. Okay. So no comments today at all. I see a couple people watching. Please chime in if you can. You can live chat as long as you have a Google account. And you can go on my blog and figure out how to do that, or just probably Google how to get a YouTube account. All right, no comments at all. So let's do the last example. Chemistry experiment, different volumes of ethanol are poured into a beaker. After each volume is poured, the beaker is weighed. Here are the results. Okay, volume and mass. Okay, so this is volume. This axis is measuring volume in milliliters. And this axis is, I'm just going to put mass down. And that's measured in grams. Okay. My minimum is 0. That's quite easy to see. And my maximum is 200. Notice again, this is a quadrant 1 graph. There are no negative numbers. This is my minimum. And this is my maximum. And I see that this maximum is very large. So I think I might do the hashtag thing again. And I can't do anything about this point representing 0, right? But I can do a hashtag for the y's when I need to. So for my x's, I need to go from 0 to 200. So I'm definitely going to have to use a larger scale than what I used above. So if I go by, let's see if I go by 25s. I think I might just make it. So I think I'm going to go 25, 50, 75, 100. 25, 50, 75, 200, and I just make it, right? So again, this comes with a bit of practice, but I'm kind of using my number sense too. I figured out how much space I have and how many numbers I use, so that kind of worked out okay. I just needed to extend my lower axis just a little bit. Okay, and let's do now. So I have to go from 90 to basically 250. So again, if I look up here, I need a much larger scale than 15s. So let's see if the 25 would work here too. I don't think so. 25, 50, 75, 100, 25, 50, 75, 200. 25, well, maybe it does. Okay, so let's do that. 25, 50, 75, 100, 25, 50, 75, 200, 225, 250. Okay, so that works. Now I just have to put a little hashtag here, right? Indicating I'm not starting, I'm like at this, the corner is 0, but I'm going to start at 25. Or actually, probably I don't even need the hashtag. I just realized that. Sorry, I don't need the hashtag this time. Now I could have started at 90, but if I wanted to start at, if I wanted to keep the hashtag, I could have kept the hashtag in and I guess called this first one 90, and then I could have used a larger scale, but 25, 50, 75, 100. You can see there's a lot of freedom in creating scales. 200, 225, 250. Now, maybe you were graphing ahead of me and you did want to use a hashtag and you wanted to start your first hashtag could have represented 90. You could have done that and then you could have jumped and gone up by tens maybe. As long as you used a hashtag, that would be fine. Okay, so let's graph this now, 0 and 90. So 0 and 90 is going to be about right here, I guess. 100 and 168. So I'm going to have to use my ruler again. 100 goes about here. And 168 is somewhere between 150 and 175. Like I'm really just eyeballing here. 50 and 129. So 50, here's the line where 50 would be. And 129 is between 125 and 150, a little closer to 125. 150 and 207, here's 150. So if I line it up here, 207 would be about here, okay? And 200 and 246, 200's at the very end. 246 is, whoops, a little down here, right? A little lower here. So we have another positive correlation. They're not all going to be positive correlations, but we have another positive correlation here. Explain what the data is to positive correlation again. Just a little word of warning, they're not all going to be positive correlations. Sometimes we'll have negative correlations, and sometimes we'll have no correlation. We'll see sometimes the data just spits out a bunch of random dots that you can't make any sense of. So in that case, we say no correlation. So this means as the volume increases, the mass increases as well. Okay, so that's how we graph data using a pen and paper approach. You look at your assignment 2 now. I scribbled this out. We're not going to do a scatter plot today in your calculator. I'll tell you how to do that tomorrow. We'll take one of these questions and we'll do it with graphing calculator Desmos tomorrow. All I want you to do is use a pen and paper approach. Take a look at your scales. Make sure you label your axes, pick an appropriate scale, plot the data, and then study the data to describe any relationships. So there's lots of space here. You only have 3 graphs to graph for homework. That's not a lot, but it takes a while to do it precisely and do it properly, right? So I'm going to assign assignment 2 for homework, and we will continue on tomorrow. What I'm going to do tomorrow is I'll take up any questions you have so far in this unit, and then we're going to take one of these questions and I'm going to do it with graphing calculator 2 tomorrow. We'll do one of our assignment 2 questions with technology, so you can see how it's done with technology. The answers are in the back. The answers are given to you with like the technology screen, the graphing calculator screen, which you can ignore for today because you're just doing the pen and paper approach, right? But tomorrow we'll find use for these and we'll kind of refer back to these when we do a couple of these with our graphing calculators. So I'll just stay on the line for a few more seconds or a minute or so to see if there's any questions from anyone in the class today. Please let me know if you have any questions. If not, you can always email me, right? You can email me through the blog, or my email address is on the course outline that I gave you. All that info is on the blog too, right? You can just go to the blog and on the math links, there's a course outline and you can find my email address. And you know how to get to the blog. You can just type in WAE. Go to the student resources. I'm sure that if you're watching me, you're probably very familiar with the course blog. So I guess that's it for today. I'll post all these notes on the blog and I'll post the video, and I'll look forward to connecting with you tomorrow. I also posted some info on the blog that every day during normal school time, I have a resource period from 10 to 11. So while school is shut down, I'm still going to have a resource period from 10 to 11. All the information's on the blog, on today's blog post, and I'll keep posting it every day. So I'll have a Google Meeting link. All you have to do is click on Kim's Google Meet at 10 o'clock, and you can ask me any question you want, any math question, if you need any help with homework or any other questions about school, you can just click on the Google Meet, and I'll be waiting for you, and I'll keep that link open and the Google meeting room open from 10 to 11 every day. Okay, so hopefully maybe I'll see one or two of you then. I guess that's it for today, and I will talk to you tomorrow.